Good morning. I'm today talking about STAC, Spatial Temporal Asset Catalog. Has anybody of you heard about STAC already? Or, well, yeah, that's great. Where do you have heard about it? Where have you heard about it?
Where?
Oh, anyway. So that's an introductory talk. I'm just giving the basics today. And the basic for this was what is annoying about metadata, right? So if you have data and want to expose that to search engines so that users can use it, so you need to basically know a metadata standard and expose it or write XML and stuff like that. And also, if you use it, you need to understand the metadata format, and we're trying to tackle that with focus on search and discovery of metadata. We may get trapped with this, of course. So if there is like 40 metadata standards, then we do a new one, and then there's 15 competing metadata standards. So that might happen, but we try to avoid this, and of course, give good reasons for why we're doing this. So first of all, like at the moment when you're trying to search for geospatial data, then you're probably getting to view any of these portals that are out there. There are like dozens of portals where you can download your data, like a Copernicus Open Access Hub for Sentinel data, or the NASA CMR, and so on and so on. But of course, to find your data, you need to know all these portals, right? So otherwise, you won't be able to find the data anyway. And we could also like go and see whether there is something like an dictionary where everybody puts in his data, or like a person that like views all the data and puts together a dictionary about them. But then we already realized that there is too much data out there. Like Yahoo is not a thing anymore, where people looked at the data and put everything into a dictionary. So we now have crawlers like for Google, for example, where everything is in one place and you can just visit Google and find everything. So we think finding things via Google or any other search engine is better than going through all of these portals to find data. And of course, like there is going on so much satellites at the moment that there are petabytes of data, and you just need good tools to find all the data. So, for example, if you're going through looking into Sentinel data, then you get this from ESA, where it says if you just want a single granule, a single tile, then you get all this data. And what you really want in the end is just maybe the metadata and the actual data file, right? So that's just these two things and this whole bunch of information that you get. And then you have to look through all these files. Like if you have Sentinel-2 metadata XML files, it's 20 megabytes of XML that you need to go through. For STAC, that's only 22 kilobytes that you can, as a normal user, can really understand. Like for example, for comparison, the plaintext Bible is just 4,000 kilobytes. So that's quite a lot to read if you want to understand the data. And you even need to find some kind of like documentation how this all works and what it actually is, the data that you're finding there, the metadata. So why we're doing this now, there are many standards and proprietary solutions also for APIs that you can, like the portals, with very similar scopes and capabilities, but it would be a good idea to basically unify them and make them interoperable so that a client can access all these APIs and all these data. That's the barrier for adoption, and so we thought about STAC could be a good idea to evolve. So what is STAC actually? It's basically defining a metadata standard or specification. It's not a standard because we're not like working for a standardization company, but it's for just a specification of what we think is useful for geospatial catalogs and assets, with a focus on search and discovery. So in most cases, you won't find any information how to process the data. There you can still link from STAC to the original metadata for processing, but to actually first find and discover the data, you can use STAC. So it's very simple. It's JSON based. So most people can really read JSON, as it's just a very thin layer on top of the metadata. And it's extensible, so you don't need to write any, like, for example, for previous things, when you had XML, you needed to write an XSD schema and adopt it, so you can add things. But now it's just JSON, where you can put your own things into that, in addition to what we have standardized already. Also, a different thing from other previous standards is that you have also static catalogs that you can crawl. So you can basically put your metadata files together with your data, or put it on top of that. Like if you have exposed Sentinel data, for example, in an S3 storage bucket, you can open another S3 storage bucket with your static files that are conformant to STAC. And then you can crawl through all these metadata files. They are linked together with links, and it's such that you don't need a server to run it. You just can put it on your file storage, and then it's there, and Google can make use of it. You don't need to write any software for that, or something like that. That's the static catalogs, and then there's dynamic APIs, of course, as well, because if there's thousands and thousands of files, you probably need to put them into the database and index them so that you can better search for them. So we also expose an API which is based on the recent version of OGC API features, the former WFS web feature service from the OGC. And we just put a thin layer on top of this standard to make it searchable. And it's an open specification, of course. That's why we're here, open source. Everybody can contribute. And so what is it not? It's not a full-fledged meta standard. As I said, it's not for processing stuff or so. It's basically really focusing on search and discovery. Although you can, if you want, put your processing information into that. It's extensible. So also, it's not a replacement for the data provider's internal metadata. So you can basically, from your item file, you can link to your other metadata or other files that you have for previews and stuff like that. It's not the single source of truth in this case. And it's also not for all kinds of data sets. So it's just for spatial temporal. And you don't really can expose things like additional documents. Like you can link to additional documents, but it's not meant for putting other things in spatial temporal data into your STAC catalog. So, and as such, it's also not a replacement for ISO standards, for example, and stuff like that, OGC, CSW. There is a recent innovation plan for OGC catalogs or records, which is also a new API, and we try to align also with this effort. So what's the state of STAC at the moment? At the moment, we're at version 0.9, just released some days ago. And we're heading towards releasing the first stable version 1.0 in mid, third or fourth quarter of this year. And there is also plans to separate the actual specification work for the metadata and the API in the next weeks, so that they're more streamlined towards their use cases. So what is this specification actually about? What do we expose there? So there are catalogs, collections, items, the API, and extensions and best practices. So what is all this about? A catalog is basically a very rough or very small thing for cataloging. You can group your collections and items with it. It's very simple. It's basically just an ID, a description, and additional links to whatever you want to group. And then a collection is basically an addition of a catalog. It extends it and adds collection level metadata to it. For example, the extent, spatial and temporal, license, provider, and all these things that you have for example, if you want to expose Sentinel data, you want to talk about what the Sentinel data actually is, which platform it is using, which temporal coverage it has, spatial coverage it has, which license, where you can find licensing information, who's a provider, and so on and so on. then this can be used standalone. So if you don't expose any assets, granules, whatever, you can only use it to expose your collections as well. Like, for example, Google Earth Engine, if you know that, just exposes their collections, and then you need to use their tools to actually use this data. So you can find this data as collection then, but then it tells you that you need to use their tools. So if there is data also which you can't download in the traditional sense, then you can at least use it in any cloud provider that is out there and exposes it as STAC collection. And collections are also useful for summarizing the actual item data that is exposed. And items itself are the actual granules, so the individual tiles. And items are basically GeoJSON features. So the feature is basically then the geometry of the asset that is exposed. And an asset, for example, in an item could be the file for band 1, and then another asset is band 2, and so on and so on. And all these assets can then be downloaded and provided with additional links, like, for example, the provider-specific metadata in ISO format or whatever. And this actually is very nice if you combine it with cloud-optimized geotiffs. So if you can see here, I'm not sure whether, yeah, that it's basically just a browser that is working on a geotiff, on a cloud-optimized geotiff. And the cloud-optimized geotiff is basically a geotiff that is a bit different structured, and with HTTP GET requests, range requests, you can basically, without any like server software, you can browse it on a map. So, for example, this is, I think, leaflet, and if you can see it, if it zooms out, then it basically, if you zoom in now, it loads the data, just the data it needs. So that there could be a 500 megabyte file behind that, and it just downloads the things you see here. So that's, of course, pretty nice if you don't want to expose the WMS, especially for that, and you can just download the data that you need and view it while discovering it, whether it contains the data you need or not. The API itself is, as I said, aligned with OGC API features. It's pretty simple, I think. There is a landing page with capabilities. There is collections that you can actually expose. For example, that would be second Sentinel 2. And then the items would be each granule that you can download here as data. And then there is the STAC-specific search endpoints where you can basically search for whatever is in the files, like whether the cloud cover or the extent or the provider or the license and so on. That's defined as Open API documents, so pretty easy to use with the Open API ecosystem as well to implement. And then we have basically for items, the metadata fields are very slim. Like there is title and extents, and there you can specify some things like when the metadata has been created or updated. But then basically this thing is in the core is very slim, and then you extend it with extensions. So for example, for content, we have extensions for describing data cubes, for EO data, which is in this case electro-optical. Then for machine learning, to specify the labels, point cloud data, for SAR data. Then we have a specific one for satellite data, which is basically inherited from EO and SAR. And for scientific data, like exposing DOIs and stuff like that. And then for the API, of course, this is also in the core very slim, and then you can extend it via fields, for example, that you can say, I don't only want to a certain set of fields in my response so that it gets smaller. You can query it via some specifics. You can sort it. And there is a transaction extension to basically add and remove fields and update fields, items and stuff like that. And of course, also for versioning, if there is like different versions of assets, then you can version that. There is a growing ecosystem behind STAC. You have, for example, already a validator where you can just put your catalog into it and it validates it, whether it's okay and according to the STAC. Then there is an extension for intake. I don't know intake, but it was said it's a big thing. In the Python world. Then there is PyStack for catalog creation and all work with STAC catalogs. And similarly works STAC. Then there is a number of clients, for example, STAC Browser, which you already saw when we had this cloud-optimized GeoTIFF preview there. This is basically a human-readable version for the catalog, for the JSON files, which also expose, for example, schema.org translations so that they can be crawled by Google and their new Google dataset search. There is a QGIS plugin. There's set search for searching data. There's set fetch for fetching the data or downloading the data. And then there's set API browser, which is basically so STAC browser was more for the static catalogs, and set API browser is more for the API part, because there you can also search, and STAC is browsers just for like going through the links that are in the data. Then there is a couple of server implementations which you can use to expose your data. For example, Staccato in Java, STAC API, which is, I think, a Node.js application, and set API PostgreSQL, which is basically, I think, Python with a Postgres database behind it. And this, for example, is a QGIS plugin where you can basically just specify your required parameters, and then it searches for data and basically loads the data directly as cloud-optimized GeoTIFF into your QGIS instance to work with. And then you can, as it's a cloud-optimized GeoTIFF, also directly zoom into that, and it loads the appropriate data and so on. We're working on basically making several catalogs available, openly available. At the moment, there are Sentinel 1 and 2. Landsat 8 and USGS Landsat Collection 2 is directly offered as STAC and COG catalogs from USGS. There's CBERS 4, which is a Chinese-Brazil satellite for Earth observation. NAAP, NASA CMR is also translated into STAC. And there are a couple of more things that are coming and are in preparation. And maybe in the future also your data. It's pretty simple to expose such things. So if you have data that you want to be found, then it's a good idea, I think, to expose it as STAC catalog. Here's an overview who is already exposing their data as STAC and working with STAC. Quite a number of entities. And now I maybe just show you a single example here. Like, for example, this one is a catalog. So it basically just is JSON. You can, I guess, most of you can read what is in there, and it's basically gives you an ID. It's Copernicus S2 here, and then a title, a description, what is it is about, a license, keywords, the provider information, the extent information, temporal, and all the other summary data that is, like, for example, the how to cite, what the ground sampling distance for the individual things is, the constellation, platform names, projection information, the bands, for example, which bands are in the actual assets that you can download, band 1, band 2, and so on, common names, wavelengths, and the links that you can basically visit to get more information. And that's a collection, and now you can basically also look at the items, which is then an individual granule. It says, for example, which ID it has, which collection it belongs to, and there is, again, links to get additional information, the bounding box of the granule, geometry, assets that you can download basically now, which is JSON files or the JPEG 2000, either a thumbnail or the actual data. And is there anything else in here? Yeah, some additional properties like cloud cover values and so on. So that's how it's working. And yeah, I'm happy to take your questions if there are any. Thank you very much for listening to this talk.
Thank you.